All right, so we're going to start here on day 2. We're going to go through our different ways to prove triangles congruent. So our first one is side, side, side congruence. If 3 sides of one triangle are congruent to 3 sides of a second, then the 2 triangles are congruent. So if we're going to write a congruency statement, remember those are our triangle ABC is congruent to, in this case, if I do ABC, I'm going to have to do triangle RST. Now remember that these do not necessarily have to be in alphabetical order, but you do have to make sure that you match up your corresponding pieces. So when we're proving our triangles to be congruent, this is where we're really going to start using our reflexive property in the way that's going to benefit us the most. So here we are trying to prove that the left side triangle is congruent to the right side triangle, and we're given a few things here in our first line. So AB is congruent to CB. I'm going to go ahead and mark those in pink. And D is the midpoint of AC. So what I'm going to do is I'm going to go ahead and mark what that means for our triangles. If D is our midpoint, then what it does is it splits AD and DC so that they are congruent to each other. Now, it doesn't specifically say that, but we are able to mark it, and then we will also fill it in our proof here in just a second. So let's go ahead and write in our given statements. Sorry about that. All right, so let's write in our given statements. It's on number 1 and number 2. And then as a result of our midpoint, that is what I could mark AD and DC as congruent. So follow what wording it has. We'll use our definition of midpoint as our reason there. Now here's where we're going to see our reflexive property. What you'll notice in this picture is that both of these triangles, the left side and the right side, both contain the same segment DB. So if I pulled these 2 triangles apart, DB would go with both of them. This is our reflexive property. We're saying, hey, in triangle ADB and in triangle CDB, that DB, it's the same piece. So this is our reflexive property. And don't forget that's one of our big 3, so we've got to put either congruence or equality after it. And then what we have here is 3 sides of one triangle congruent to 3 sides of another. So these 2 triangles are congruent by side, side, side congruence. Our second is side angle side. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second, then the 2 triangles are congruent. So if I want to write a congruency statement, I'm going to have triangle RST is congruent to triangle UVW. And notice here I highlighted the words and the included angle. So we have a side and another side, and the angle that is wedged between the 2 sides, side, side, and the angle that is wedged between the 2. So this is our side angle side congruence. Notice here that this angle is wedged directly between those 2 sides. So things we're going to look for before we begin this proof, and this is just on a general basis. We're going to look for vertical angles because we know that vertical angles are always congruent. We're going to look for pieces that are part of that reflexive property. Are there any shared side or angles that we can then use to be congruent? And do we have any parallel lines? Because if we have parallel lines in our given statement, then we know that they're going to lead us to some congruent angles. So if we think about these 3 things, we're going to write this proof here. We're given that JN and LN are congruent, that KN and MN are congruent. And we want to prove the 2 triangles are congruent. So if we look here, JN and LN are congruent, KN and MN are congruent, and that is given. And then here, if we look at our big three things to pay attention to, we do have a set of vertical angles. Angles JNK and LNM are vertical. We've also numbered them with number 1 and number 2 to just make it a little bit easier. So these are vertical angles, and we know from our vertical angle postulate that vertical angles are congruent. So our triangles then are congruent by side, angle, side congruence. Two sides and the included angle of one are congruent to two sides and the included angle of the other. Next we have angle, side, angle. Notice we flip-flopped our letters. If two angles and the included side of one triangle are congruent to two angles and the included side of a second, then the two triangles are congruent. So notice here we have an angle and the side wedged between the two. Angle and an angle and the side wedged between the two. So this is angle, side, angle congruence. And again, this side is included right in between those two angles. So we're going to complete our proof here. Let's go ahead and mark up all of our given statements. WU is parallel to YV, so that's step number 1. And XU is parallel to ZV, that's down in number 3. And there's a typo down here, but WX is congruent to YZ, that's actually step number 5, that is also given. So these things are marked in our diagram here, and let's focus on our parallel lines. So if I look at WU and YV, that's these two here. Remember that parallel lines are going to lead us to some congruent angles. So if I focus on those two parallel lines, my transversal is this ZW. Well, if I take a look at these two parallel lines and that one transversal, I notice that they are creating some corresponding angles. And I'm actually going to number those angle 1 and angle 2. So let's see. In our statements here, UWX, so that's what we have listed as angle 2, and angle 1 are congruent because if my lines are parallel, then my corresponding angles are congruent. Now let's look at our other set of parallel lines. I have ZV and XU. And again, they share that common transversal. And what I see here is that I have another set of corresponding angles. So let's see. UXW, so I'm going to name this one 3 and 4. So angle 3 is congruent to angle 4 because of the same reason. If parallel, corresponding angles are congruent. Remember that this if parallel must be there because corresponding angles are only congruent if we first know that our lines are parallel. And so now what we've got in our diagram, if I erase these parallel lines here, is I have two angles and the side wedged in between the two. So this is our angle, side, angle congruence. The next one is hypotenuse leg. So if the hypotenuse of a right triangle, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of a second, then the two triangles are congruent. So here we have two right triangles. So our first checkbox is it a right triangle? And is the hypotenuse congruent to the hypotenuse? And is a leg congruent to a leg? Okay, not every right triangle will be congruent to another right triangle via hypotenuse leg. You can still have angle, side angle, side angle, side, 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 side for right triangles. It's not always just hypotenuse leg. So if we take a look at this picture over here, we are given that AC and EC are congruent. And we are also given that we have some perpendicular lines. So AB is perpendicular to BD. I'm going to go ahead and mark that as perpendicular. And ED is perpendicular to BD. Those are also given to us. So the first thing that we're going to do if we want to use hypotenuse leg is we have to say that we have a right triangle. So if we know that our lines are perpendicular, then I know that there are some right angles that are formed. And those are at angle B and angle D. So those are right angles. And again, if we want to use hypotenuse leg, we have to say that we have right triangles. So that's the step of number 4. ABC and EDC are right triangles. Definition of a right triangle. Right triangles have right angles. And then our other given statement, AC is a bisector of BD. So what that tells us is that BD is split in half. Which creates segments that are congruent, BC and CD. Now if we look at our picture, here's where we have the hypotenuse and the leg of one right triangle congruent to the hypotenuse and the leg of another. Therefore, we can use hypotenuse leg congruence as our reason for them being congruent to each other. Our last one here that we're going to talk about today is angle-side congruence. Notice the order of our letters. If two angles and a non-included side of one are congruent to two angles and the corresponding non-included side of a second, then the two triangles are congruent. So if you look at these pictures, we have angle and a side that is outside of those two angles. Angle, and a side that is only attached to one of those angles. So again, here we go with our proof. BE is congruent to BC, and angle A is congruent to angle D. So let's get those listed in here in our given statements. BE is congruent to BC, and angle A is congruent to angle D. Those are given to us. And you can list it as 1 and 2, or you can just leave it as number 1. Now, think of our three things. Do we have any reflexive pieces? No. Do we have any vertical angles? Yes. So here at angle B in the middle, we have vertical angles, and I'm going to number them 1 and 2. The last thing we want to do is name them as angle B, because technically there are 4 angle B's there. So we can say angle 1 is congruent to angle 2, because we know that vertical angles are congruent. And number 3, that gives us enough here to prove angle, side congruence. So triangle ABE is congruent to triangle DBC, because angle, side congruence. So we've got 3 things. Well, we have more than 3 things, but let's talk about ways to prove congruence. So yes, these work. We have angle, side, angle congruence. We have side, angle, side congruence. We've got side, side, angle, side, and hypotenuse leg. Now, there are a few combinations that do not work. One of those is angle, angle, angle. One reason that this does not work is if I ask you to draw me an equilateral triangle or an equiangular triangle, those all will be 60-degree angles. But one thing that you can see is that if I take my equilateral triangle and I go ahead and mark all of those side lengths the same and all of my angle lengths the same, one thing that we can do is we can take that same triangle that is equiangular and I can make it bigger. And you'll notice that these angles are all still congruent. Okay, so angle, angle, angle is not enough to prove triangle congruency. The other one is side, side angle. Now, if you read this one backwards, angle, side, side, I want you to remember no donkeys. If it makes a word that you're not supposed to say at school forwards or backwards, then it is not a way to prove triangle congruency. And we'll talk a little bit more about why in class. It mainly has to do with that additional side and its placement. If I were to ask you guys to create some triangles based off of side-side angle, there would be two variations that the class could come up with. Whereas if I work with any of the others, everybody is going to give me the result of the same exact triangle as everybody else. So two things that don't work, angle, 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 so no yelling. And side, side angle or angle, side, side, no donkeys.